Good day, class. I remain your favorite tutor, Adeyeye Adele Picture. Right now, I want to look at the resultant of forces inclined at an angle theta to each other when two forces are inclined at an angle theta to each other. So how do you handle the resultant? Okay. So you are going to apply the law of parallelogram of forces here, because what you are going to do here, you are not going to find the resultant just like we did for parallel forces. But before I use the law of parallelogram of forces, let me show you how vectors are added. Vectors that are at an angle to each other. So if you have a force in this direction, let me call this one F1. F1 takes off from the origin here. This is O. And then it now changes direction and goes this way. So that is F2. And the journey ends here. I will call here E, which is the end point. O is the origin, E is the end point. Now, according to the law of vectors, that's according to vector addition, it is the same thing as someone traveling from here, from the origin, and taking this straight path, this singular path. If I call this one F3, so according to vector addition, F3 is the resultant of what? F1 and F2, so that F3 will now be equal to what? F1 plus F2. Now you can see that that F1 and F2, they are at an angle to each other. So anytime you want to find the resultant of two forces at an angle to each other, this is how the diagram must look like. The resultant must meet the other two forces. Just like the resultant will double cross the other two forces. So when this is the first force going in this direction, and then this is the second force continuing the journey of the first one, then the resultant will what? We meet the two of them. We double cross them. So that from here to here is the same as someone traveling from here to here, then changing its course and then moving to this place. So as far as the journey starts from here and ends here, is the same as the journey starting from here and ending here. So since they start from the same point and they end at the same point, so the person going this way is the same as the person going through here first and then turning here. So that F3 is equal to F1 plus F2. But mind you, this is not just algebraic addition, as I told you. You can't do this like you did for forces that are parallel to each other. Now, this addition is what we do in mathematics when we use cosine rule. I believe you understand trigonometry very well in mathematics, where when you have a triangle, if you have a triangle, so that you have two lines, A and B, that are inclined at an angle theta, let me say theta, to each other. So you have two lines and the included angle. I believe you know the meaning of an included angle. Included angle for two lines is the angle that is formed when those two lines meet, the angle that is formed between those two lines. Now, if you have the third side to this triangle, and that third side is C, small letter C. So you can be asked to find the third side. So given A and B, and then the included angle theta, if you're asked to find C, so what do you think C is going to be? C square, use cosine rule, right? Cosine rule, I believe you still remember cosine rule. C square will be equal to A square plus what? B square minus 2 times A times B, that's 2AB, then cos what? Cos theta, which is the angle, the included angle between A and B. So that is what this one also means. So it's not just algebraic addition, such that F3 square is equal to what? F1 square plus what? F2 square minus 2 F1, F2, then cos of what? The angle theta between F1 and F2. The two forces whose resultant is to be found. So there must be an angle between them. So that's cos what? Cos theta. All right. Are you following? Now, please let me use one more diagram to explain this vector addition. What if you have somebody starting his journey from here? This f1, then it changes direction. This f2, it changes direction again and ends the journey here. This f3. We call this one the law of polygon of forces. Now, one person now just comes, start from the origin and ends his journey here. So I call this one f4 so that here's the end point. Or let me call this f5. This f5. Now, I hope you know that f5 will be equal to what? f1 plus what? f2 plus what? Plus f3. There are more explanations to these things, but I didn't have time to expand it. Okay? In fact, let me call this one equation 1. Now, let me draw a diagonal in between this quadrilateral. You know, this is a quadrilateral now, right? So let me draw this diagonal here so that this one is a 4. So let me call this one f what? f4. I intentionally call this one f5. I'm going somewhere with that. Are you following? So this is f4. So if you look at the first triangle, this is the first triangle. This is second triangle. So because we have two triangles now, in the first triangle, which one do you think is the resultant of the other forces? Guess f1, f2, f4. Which one is the resultant? F what? f4. You're correct. So f4 is going to be equal to what? f1 plus f2. Okay. Call this one equation what? 2. Then look at the second triangle here. What do we have there? We have f3, f4, f5, right? So which one do you think is also the resultant of the other two forces? So I told you that your triangle must always look like this. The resultant must double cross the other two forces, okay? F what? F5. So F5 will be equal to F4 plus F3. So call this one equation what? Equation 3. Now, what did I say F5 is? So let's do backward substitution. So we substitute backward from 3 to what? To 1. So F5 now, right? So F5. Now, what is F4? So substitute now. F5, I want to repeat this now, but that's to get this one back. So what is F5? F5 is F4, right? But what is F4? Only F4 gives what? F1 plus what? Plus F2. Then, so only this one now is what? F4 plus what again? Plus F3. So you can see that this still gives this. So that's the law of polygon of vector or of forces. All right. And I think I've told you the implication of this addition, that it's not just algebraic addition. All right. So from there, let's move to the law of parallelogram of forces. The law of parallelogram of forces. I want to be as fast as possible. I don't want the video to be too long. So we look at law of parallelogram of forces. And what does the law say? These are laws you must know offhand. So the law of parallelogram of forces states that if two forces acting at a point can be represented in magnitude, since it's a force, right? So it must have magnitude and direction by the adjacent sides of a parallelogram. So that's why they call it the law of parallelogram of forces. The resultant can also be represented in magnitude and what? And direction by the diagonal of the parallelogram drawn from that point. So quickly, let me draw a parallelogram to explain what I mean by that. I believe you know how a parallelogram looks like. Okay, those are basic shapes, plane shapes. Okay, so plane shapes. That's one of the plane shapes we have. A parallelogram is one of the quadrilaterals we have. Okay, so something like this. Make sure that the opposite sides are parallel to each other. Okay, so this is a parallelogram. Okay, this and this are parallel to each other, while this and this are parallel to each other. So if I call this one A, I call it what? B. So definitely, if here is A, the opposite side will also be what? A. Then if here is B, the opposite side will also be what? B. All right. Now, according to the law of parallelogram of forces, it says if two forces acting at a point are represented in magnitude and direction by the adjacent sides of a parallelogram, adjacent sides. So now, what do we mean by adjacent sides? Any two sides that touch each other are what? Adjacent sides. So for example, A and B are adjacent to each other. So these two adjacent, these two also, these two sides, here and here, adjacent, here and here, adjacent, and then here and what? And here. So all those pairs, they are adjacent to each other. So represented by adjacent sides. So these are the two adjacent sides, okay? Now, it says the resultant can also be represented in magnitude and direction by the diagonal of the parallelogram drawn from that point. So now, assuming this is the point where the two forces are acting, one is acting towards here, the other one is acting towards here. Then what do? You draw the diagonal. Draw a diagonal here. Don't this parallelogram has two diagonals. You can draw one here. You can also draw one here. But you draw from that point, from the point where they are acting. So this is the resultant now. So the resultant is also acting from where? From here. Are you following? Are you following at all? So this one acting this way, the other force acting this way, so that the resultant will now also be drawn from that point. So this point acting at a point, they are acting at a point. Then the resultant will also be drawn from where? From that point. Can you see what I mean by that? So anytime you are given two forces inclined at an angle to each other, you must always get what? A parallelogram. So let me give you an example. So if this is the first force, this is the second force. I want to explain better, please. This is second force. This F1, this F2, and this what? Theta. This angle theta, the angle between them. So these two forces are acting at this point O. They are dragging, there's a particle here. So this one is dragging, F2 is dragging a particle towards there, while F1 is dragging upward in that direction. So that this is the point both of them are acting at. Now, the resultant will now be drawn from where? From that point towards this what? Direction, because you must also indicate the resultant with both magnitude and what? And direction. So this is the magnitude of the resultant, FR. Then you will now complete this, you will complete this parallelogram yourself. Can you see? Please make sure you draw something now. Draw a line parallel to what? To this. This is horizontal. So see the way I'm going to draw this. Can you see? Then draw another part. Now this one is F what? F2. So draw another parallel line from here now, from where this F2 touches the resultant. So you draw another parallel line to F1. So this is the other parallel line. So that this one too is what? F1. F1 is acting upward, isn't it? So let this one too face up. This F1. Okay. So you can clean here now. All right. Now look at these diagrams very well. You will notice that the resultant, which is the diagonal now, has divided the parallelogram into two, so that we now have two triangles. We have two triangles, right? So let me bring out each of the triangles. The first one looks like this. First one looks like this. Can you see? This FR, this F1, this F2. Now, but please, for your information, you don't know what this angle is again. Don't tell me that theta has been divided into two. The diagonal of a parallelogram does not bisect the angles. So please, you don't know what this angle is, and you don't know what this angle is, but you know the whole angle, the angle of inclination between the two forces from the origin. So you don't know what this angle is. Now, this is the first one. What do we need now? We need this angle now. Look at this. This looks like the triangle I drew the other time. Now, I drew a triangle like this before. I said F1, F2, and what? FR. So that this one is the what? Is the resultant. So they look alike. So that if this one is FR now, you remember that formula? FR square will now be equal to what? F1 square plus F2 square minus what? 2F1, F2 cos of this angle. Now you can see that it's not even this angle we need now. What do we need? We need this angle. You can see. But this angle has to be expressed in terms of what? In terms of this. Now if you are using the other triangle, you are going to have something like this. You can use any of the two triangles to find your resultant. You can use any of them to find your resultant. So the other triangle will look like this. You have something like this, right? Okay. So that this FR, this F what? 2, this F1. Now you don't know what this angle is. Now look at this. From here, I can say FR equals F1 plus F2 from the first diagram here. Look at this one too. You will notice that since here is the origin, look at F2. F2 is the one that starts the journey from the origin this time around. Unlike here, where F1 starts the journey. Now, I can also write that FR, which is the resultant force, will now be equal to what? F2 plus what? Plus F1. No, F1 ends the journey. This is the end point. Don't forget. For this one, here's the what? Here's the end point. So FR is F2 plus what? Plus F1. Now, look at these two equations. They are the same thing. This is what we call the law of commutativity under binary operation. So that the order of arrangement doesn't matter. For addition is what? It's commutative. If I say 1 plus 2 is the same thing as 2 plus what? Plus 1. So they are the same thing. So F1 plus F2 is the same thing as F2 plus F1. So you can use the same thing. But the only difference is that this angle here is going to be different from this angle. Because this is the angle the resultant makes with F1, while angle beta here is the angle the resultant will make with what? With F2. Alpha is the angle the resultant makes with F1, while beta is the angle the resultant will make with what? With F2. So let me quickly give an example to buttress my point. Let me write the example here. Find the resultant. Example, find the resultant of two forces, 8 Newton and 10 Newton inclined at angle 60 degree to each other. Solution. So you draw a diagram. This the first force. This the second force. 60 degrees acute, right? So this 8 Newton. This 10 Newton. 10, your 10 can be here and your 8 here. Anyhow you want to arrange it. So this is the origin. Now 60 degrees acute. So you must use your initiative to draw your diagram. So here is 60 degree. Then what happens? You draw your resultant. Let it pass through the point of intersection in between them, directly in between them. Can you see? Then you use arrow to show your result, and this FR. Then you complete the parallelogram. Draw a parallel line to this one from here. So this also 10 Newton in the same direction with this 10 Newton here. Then come here from the point of intersection here, where this 10 Newton means the resultant. Draw another parallel line to this one. Okay, so this is what? 8 Newton. So you can clean this part. Okay. So yes, 10 Newton. So this is the resultant. The class, we need this angle now. So what do you think this angle is? This angle is what? Now, opposite angles of a collateral are what? Are equal. So if here is 60, what is here? Here is also what? 60. So now we don't know here. We want to find here. So call here x. Call here what? X. Then what is the sum of angles of a collateral? 300 what? And 60 degrees. The sum of the interior angles of any collateral. So that's going to be x plus what? 60 plus 60. Everything should give you what? 360 degrees. So x plus x is 2x. 60 plus 60 is 120 equals 360. So 2x equals like times. That 360 minus 120. That's what? 240, right? And x will be 240 over 2. That's 120 degree. So it means this angle now is 100 and what? 20 degree. 120 degree. 1 what? 20 degree. Now you don't need to go through this route always. Just remove this angle from what? From 180. You are going to get the angle here. Just the angle from the origin here given to you. Remove it from 100 and what? And 80. There's another proof for that. I can use corresponding angles. Notice it. If here is 60, produce this angle. This line, produce this line. This one, this line now, this horizontal line serves as transversal to this and this. 8 Newton, 8 Newton. These are parallel lines. So if here is 60 degree, here is what? 60 degree. That's corresponding what? Angle. I don't mean you didn't know here yet. That's corresponding angle. Then this is a straight line, isn't it? This is a straight line. Angle on a straight line. So 180 minus 60, 120 degrees. So if here is 120, here to be what? 120. Opposite angles of a parallelogram. So we can bring out any of this now. Any of this now. Clean here. Put alpha here. That's the angle between the resultant. Between the resultant and 8 Newton. Then here put what? Beta. So you can find the resultant, then find any of these angles to show the direction. So any of these angles will give you the direction of your resultant force. So let me bring out the triangle at the top. You can use any of the triangles to find your resultants. Don't forget. So we have this. We have this. We have this. Then this is 8 Newton. This FR, this origin, this 10 Newton, this alpha. We need this. Then this 120 degree. So you remember FR what? Square equals F1 square plus F2 square minus 2F1 F2 cos what? Cos theta. So that's going to be 8 square plus what? 10 square minus 2 times 8 times 10 times cos 120 degree. That's 64 plus 100 minus 160 times minus 0.5. 0.5, right? So this is going to be equal to 164. Then this minus times minus, that's plus. Then that's what? 80, which is 244. FR square. FR square is 164 plus 80, that's 244. So FR square, then FR will be square root of what? 244. And that's what? Square root of 244. That's 15.62 Newton. Now don't forget, this is just magnitude. Now we need direction. This is direction. We need direction now. The angle between the resultant and this particular 8 Newton force. So what's the direction? So we use cosine rule to find the magnitude of our resultant. Now we are going to use sine rule to find the direction. Your trig, I believe you can still remember sine rule. Okay? We are looking for alpha. We know the side opposite to this angle. Then we know this angle, 120, and then the side opposite to it, which is our resultant. So that's going to be sine alpha over what? 10 equals sine what? 120 over the opposite side, which is what? FR. And what is FR? 15.62. Are you following? So cross multiply, you are going to have 15.62 sine alpha to be 10 sine 120 degree. So 15.62 sine alpha is 10 times 0.8660, which is 8.660. Then sine alpha is 8.660 over 15.62. That's what? So we have 8.66 divided by 15.62. That's going to give us 0.5544. So that alpha will be equal to sine inverse of 0.5544. And what do we have there? That's sine inverse of answer, that's 33.7 degree approximate value. So you can now conclude and say, therefore, our resultant, therefore, the resultant is equal to magnitude first, 15.62 Newton. At what angle now? At angle 33.7 degrees. To what first? To the 8 Newton. If you find better, if you use the other triangle, you are going to find better. That's the angle between the resultant and the 10 Newton force. Okay, so this is our answer. The 3 point. Now, if you find that better is going to be 60 minus this answer. If you use the other triangle, you're going to get 26.3. So I think you should try the other triangle. Use the other triangle, find better, then confirm my answer. The angle should be 26.3 degree. So my next video, I'm going to be dropping resolution of forces. I'm going to do component of forces in a particular direction, and then I will do resolution of forces. Okay, resultant of forces of more than 2 forces. You can have 3 forces, 4 forces, 5 forces, 6 forces. So, and you'll be asked to find the resultant. So thank you for your attention. Like this video. You can comment your suggestions, and then please subscribe and share. Thank you.